similar triangles and trigonometric ratios. In ancient Egypt, finding the height of tall objects was next to impossible. Thales, a Greek philosopher, scientist, and mathematician, visited the Great Pyramids 2,600 years ago. He discovered that using similar triangles and shadows of objects that were measurable allowed him to measure the height of the pyramids. Do you recall similar triangles? What properties do you remember about their angles and sides? In similar triangles, the corresponding angles are congruent or equal in measure, and their corresponding sides are in proportion to one another. Because similar triangles have congruent angles and proportional sides, we can use a triangle with a hypotenuse length of 1 to show how trigonometric ratios are created and see how they apply to all triangles. We have these two triangles. They both have a right angle and this angle alpha. If we take this red triangle and we drag it over, it overlaps directly with the ends of our original blue triangle that we had there. So we can clearly see that these two triangles are similar. What we can do with this is we could actually take every single side length that we have and divide it by the hypotenuse. Now the hypotenuse divided by the hypotenuse is going to give us 1. Opposite over hypotenuse will give us the sine of alpha, and the adjacent side over the hypotenuse gives us the cosine of alpha. As we saw in the previous slide, the ratios of the similar triangles are equal. This means that the sine and cosine ratios are defined by this three-way ratio. Opposite to adjacent to hypotenuse is equal to the sine to the cosine to 1. It also follows that the opposite over the hypotenuse is equal to sine over 1, which equals the sine of alpha. And the adjacent over the hypotenuse is equal to the cosine of alpha over 1, or the cosine of alpha. If we change our reference angle from alpha, which is down here in the lower right-hand corner, to beta in this upper left-hand corner, we can also show that these two triangles are similar. Because if I overlap them, we can see the betas match up and they both have a right angle at the one corner. So again, we have similar triangles in relation to the angle beta. There are two acute angles in a right triangle. Let's focus our attention on angle beta right now in our figure to the left. In these diagrams, the names opposite side and adjacent side are named with respect to beta. And again, if we overlap it, we can see that the beta values are indeed equal to one another. So again, we have opposite to adjacent to hypotenuse will be equal to sine of beta to cosine beta to 1. And it follows that the opposite side over the hypotenuse is equal to the sine of beta over 1, which is equal to the sine of beta. And that the adjacent side over the hypotenuse is equal to the cosine of beta over 1, which simplifies to the cosine of beta. So therefore we have our trigonometric ratios. The sine of theta over 1 is equal to the opposite side over the hypotenuse. The cosine of theta over 1, or the cosine of theta, is equal to the adjacent side over the hypotenuse. Notice the order and the corresponding sides are matching up. And finally, the tangent of theta is equal to sine over cosine, which is equal to the opposite side over the adjacent side. When working with trigonometry, you'll need to find the values of sine, cosine, and other trigonometric ratios when given an angle. This used to involve tables, but now it's pretty simple to use a basic scientific calculator. Basic scientific calculators are available on computers, tablets, and smartphones. They can also be a separate device, similar to the inexpensive calculator shown here to the right. It can do everything that you'll need for this course. The trigonometric functions, or trig functions for short, that we are going to be using right now are the sine, cosine, and tangent ratios. And on most calculators, they are noted by buttons which say their abbreviations. So SIN means sine, COS means cosine, and TAN means tangent. So the SIN, or sine button, is for finding the sine of an angle. The COS, or cosine button, is for finding the cosine of an angle. And the TAN button is for finding the tangent of an angle.